Greetings. I'll be doing problem 2, including the bonus problems. Here I've got a point class, and then I've got the class that I'm going to use for my tester. Let's go ahead and paste in the requirements for this class in a comment so that we can be following along just in this document and we won't have to switch back and forth. Alright, here we go. If you haven't seen this before, /* followed later on by a */ is a way of commenting multiple lines at once. So anything that I put in between those two is going to count as a comment. Alright, so I've got to have a constructor, which takes an xy coordinate. I've got to calculate the distance to another point object. I've got to say whether or not my point is to the right of another point object. And I've got to say whether or not my object is close to another point object. So let's start with fields. You should always mark your fields as private. And I'll tell you what that means in a second. So we'll have private double xy. Let's make the constructor. So I think it's good practice for you to have your fingers just know how to type common things. So public point double x double y. So that was like pretty quick and fluid. Most editors will actually let you automatically generate constructors and getters and setters automatically. So inside IntelliJ, you can hit Control-Shift-A, which is a search dialog that will let you know what hotkeys are. So I want to generate, and here the top hit says generate is Alt-Insert. Okay, so I'm going to hit Alt and Insert, and then I'm going to generate a constructor. And I'm going to generate the constructor using both x and y, and I click OK, and there you see it's done the same thing. It's made my constructor. All right, let's go ahead and write the entire skeleton first. So a great thing to do in your programming is don't fill in the logic of the methods one at a time. Instead, get your entire structure down first, and then go back and fill in the logic. So public double distance 2, I take a point as an input. And now just to return something, I'm going to return 0. Now public boolean is right of point other. So I'll return false. And then, oops. And then public boolean are close point other double amount. Okay. Return false. Great, so now I've got the structure in place. Okay, I've gotten split screen here to explain something before we write distance to. So on my right is the point class. On the left, this is going to be the client class, which actually uses the point class to make point objects. So let's go ahead and just make one first. So point is the data type. I'm going to call it P, and I'll say new point, and I'll give it an XY coordinate. You'll notice that this is different than Eclipse. IntelliJ has filled in this X colon and Y colon. But you see it does this automatically, like I'm not typing X colon Y colon. If I hit 3, it automatically fills it in. And it fills it in based on the name over here. So if I call this A, notice that this now says A. So this is just a convenience in the display that reminds you what do these numbers mean. Oh, this number is getting assigned to X, this number is getting assigned to Y. All right, great. So a couple of people were confused about the input to distance to. So several people did this. They said, well, if I'm finding the distance, I've got to give it an X coordinate and a Y coordinate like this. But that's not what I had in mind. What I had in mind is just give it a point object, because inside a point object, there already is an X and a Y. So it's a more compact way of passing around your information. It also makes more logical sense because we never want to talk about XY coordinates other than being linked together as being facts about a point object. So because a point object is really kind of what we want to be talking about, let's not pass in separate variables. Let's just deal with the object itself. Okay, a second confusion was some people were thinking, well, okay, distance requires 2 points, right? I'm finding the distance from one thing to another thing. So shouldn't I have like 2-point inputs, like 0.1 and then some 0.2, and I'm finding the distance between this one and that one? And the answer is also no. Because if you remember, these methods, these are the behaviors that a point object has. Or put differently, these are like questions or requests that you could make of a point object. So over here in my client code, now that I have a point object, I could say p dot. And now that I've had the dot, these auto completions are coming from over here. See how it says distance to is right of r close? So let's look at the list again. R close, distance to is right of. So those are coming from my structure that I've typed in here. So if I want to know the distance, if I say p dot distance to, let's make 2 points. So here, p2 equals new point at 10, 10. So p dot distance to, I'm being requested to give a point object here as input, and the 2 points that we're finding the distance between are the point that's running the code and the input. So if I ask my point p to find the distance to p2, it's the point from myself, from p to p2. If I had other points, like let's make a p3 really quickly, at negative 10, negative 1, negative 10, I could have p3 find its distance from itself to p2. And just doing that by itself, this on a line by itself would be weird because distance 2 is returning the answer. Like we're asking the question, what's the distance? And it's returning a double. So I would need to assign that double to some variables. So here, this on the right-hand side is going to run, it's going to return the double, and now we're saving it into dist. All right, so it's important to understand how your methods are going to get used before you actually write them, because otherwise it's very likely that you're going to do something that doesn't make sense. So with that said, now let's go ahead and write it. So we've already written the distance method in a previous problem set. It's just the distance formula. So let's do this. I know I want something like this. I'm going to have a difference in x values. So normally it would be like x2 minus x1 would be my difference in x values, and my difference in y values would be y2 minus y1. But the problem is, where am I getting my x2 and my x1? Well, I know that one of the x coordinates I'm using is my own x coordinate, because it's a point object that's running this. So I'm going to say this dot x, because I want to know my own x coordinate. And then the other x coordinate is the x coordinate of the other point. That's the input point. So here I can say other dot. Well, at this point, I could say other dot x, and this is actually okay, even though it's marked private, because this is an instance of the point class, and we are the point class. So what private means is that only the point class has access to these. But this is generally considered bad design. Let's write a get method. I don't have one right now, so I'm going to go ahead and create one. I'm going to create getX and point. Actually, let's not do it that way. Let's do the auto generation. So down here at the very bottom, I'm going to hit Alt Insert. I'm going to generate. Only this time I'm going to generate getters and setters, and I'm going to select both of those. And as you can see now, I've got getters and setters. It's pretty standard practice to just have getters and setters. Well, there's some dangers there, which we'll talk about later, but it's pretty standard practice to just generate getters and setters for all of the variables that you want to be publicly alterable for your class. All right, so enough talk. So we've got this.x minus other.getx. We've got this. Actually, so now we can even do this.getx. So this is actually probably my favorite thing to do. Get y minus other.get y. So even when it's your own class, get everything through your own getter methods. And if you're wondering why, there's a longer story, but let's just say this is going to make debugging easier later when your objects are very complicated. All right, so distance formula, I'm going to return math.square root of diff x times diff x plus diff y times diff y. Because it's like x squared plus y squared square root, right? So now we've calculated the distance. And at this point, you should probably test it. In fact, yes, let's test it. It's good to have short coding testing cycles so that you're sure that you don't introduce a bug that then later on it'll be hard to find because you're not sure, there's so many untested things you don't know where to look for it. So let's do this. I'm going to create 2 points where I know the distance between them, which will make it'll just be like a little sanity test. This is not extensive testing, but let's make a point at 0, 0, and now let's make a point at 10, 0. And so now if I say system.out.println, p.distance to p2 should display 10 because I know it's only one dimension, it's just 10 away. So let's see what happens. Great, so it says 10. So that was a good sanity check. Let's do this. Let's do 10, 10. So let's run it. So 14.14, are we expecting that? We'll imagine this is a triangle. So the base of the triangle is 10. The height of the triangle is 10. I want to know the hypotenuse. So that's like, do I have a calculator here? Well, I don't have a convenient calculator, but it would be the square root of 100 squared plus 100 squared, and suffice it to say this is correct. All right, so we've tested this. We're pretty sure this works. Let's go to is right of. So this one is supposed to return true if the input point is to the right of the point that's running the code. And that's true if the input point has a larger x variable. So I could say if other.getX is greater than this.getX, then I'll return true. Otherwise, I'll return false. So this would work. This is actually longer than it needs to be because notice this test right here is returning true or false. So if I wanted to, I could actually break this test out and save it into its own Boolean variable. Test result. You might not have known that you can do this, but this is sometimes convenient. So then I could say like test result here. So if test result is true, return true. If test result is false, return false. So that's silly because this is giving us a yes or no answer. Is it true that this is bigger than that? And then depending on what the answer is, if the answer is true, I return true. If the answer is false, I return false. So why not just return whatever's in the answer? Why not just return test result? Because it's the same. If this was true, I would have been returning true. If this is false, I would have been returning false, and that's what this does. And so if you think about it that way, now it's actually superfluous to even save this into a variable. I don't need to do it because the whole point of this variable is just to return it. So instead, I could just return this directly. Oops. I could say return this. So we've reduced something that was 4 lines to something that was 1 line. So this is like a pretty typical clean way of writing this. The logic there is a little bit confusing, and if it is, there's actually nothing wrong with doing it the other way. That's just fine. But for people who like their code to be like really polished and nice, I think this is a good practice. Okay, let's write the rClose method. So this is about testing if the current point that's running the code is close to this other point. And closeness is measured as being a smaller distance than this distance. So what a lot of people did was something like this. They like copied and pasted, or maybe they retyped whatever it was that they did for calculating the distance. So dist. And then they did this. They said if distance is less than or is less than amount, then return true. Oops. Come on. Otherwise, return false. All right, so this is fine. This works. It's much longer than it needs to be. This is just a repeat of code that we already wrote. And the whole nice part about making methods is so that you never have to write this code again. So instead of retyping the code, let's just do this. Let's say double dist equals this.distance to other. So this is the current object, and it's running its own method to see the distance to the other. Equivalently, you could do this. You could say other.distance to this, and that would do the same thing. It's a little bit, I don't know, I think it's a little bit weirder. So that's nice. We've already made it shorter. And then what I just said is this is an example of the same trick as the is right of. I don't need to have all of this. Really, I'm just returning the answer to the question, is the distance less than the amount? If distance is less than amount, this returns true, and I would want my method to return true, so that works. And now that we've done this, there's really no point in having distance be right here. So I can paste this in there, and now the entire thing is really just one line. Oops, now this is there. So now when I'm reading this, I'm saying, okay, return if the distance from this to the other is less than amount. Don't think that your goal is always to make things be as short as possible. There's a balance. Really what you want is for things to be as readable as possible. So I could understand if someone thought that this was actually less readable than this version. And in that case, you should actually go with this version. Because it's not important to try and minimize everything at all costs. The whole goal is to make things to be easy to understand and easy to debug. So you should do whatever makes those things the easiest. And actually, in this case, I think I prefer the 2-line solution to the 1-line solution. This feels to me sort of like the right level of clean. All right. Oh, is that it? Yeah, cool. I think we're done. Okay, so let's do part B. Let's do that in a separate video.